Welcome, everybody. My name is Sean Manzanares. I'm a senior manager of the Business Strategy and Marketing Group, working on the market development for North America and Asia Pacific. Autodesk makes software for people who make things. If you've ever driven a high-performance car, admired a towering skyscraper, used a smartphone, or watched a great film, chances are you've experienced what millions of Autodesk customers are doing with our software. In June of this year, President Moon Jae-in declared a manufacturing renaissance vision to turn the country into one of the world's top 4 manufacturing powerhouses by 2030. This will accelerate manufacturing innovations with a focus on making things smart, such as smart factories, and increasing the adoption of advanced technologies, including artificial intelligence based in manufacturing, also eco-friendliness, and 3, a convergence. This vision prioritizes nurturing talent and technology adoption. Korea is aligned with Autodesk, and this is what we call the future of making. I love what this image captures. As a manufacturer of products, this image may resonate with you. To me, I see speed. I see competition. I see the drivers trying to gain an advantage of speed. Are you the lead car or are you the trailing car? Bottom line is somebody is in front and they have a distinct advantage. This is the same with technology. Are you using the latest technology to help you go from second place to first? Or do you have enough technology to stay in the lead and grow that lead? This is about competitive separation, and today I'd like to share with you how the tools from Autodesk can help you drive that competitive differentiation and separation. I meet a lot of people and I ask them, what do you know about Autodesk? And they tell me, you're that AutoCAD company. And to that I say, yes. 37 years ago, we invented CAD, or computer-aided design and drafting. This legacy has put us in the position we are today as a market leader in what we do in terms of design and manufacturing technology. For those that don't, let's watch a quick video that showcases where we are at with Autodesk and our products. Every time I watch that video, I smile and I capture something new. And this video really showcases who Autodesk is. When you look at us in terms of the media and entertainment, commercials, gaming, movies. If you look at our architectural engineering construction business, you can see the tallest skyscrapers and the software that we use to design that. I'm here representing our design and manufacturing group today. A lot of our technology on display in that show reel as well. One thing is for certain, our customers are in control and manufacturers have a problem. Our customers expect, actually they demand more innovative and better products. The good news is that new manufacturing technologies and material innovations offer tremendous promise to do just this. But there is a problem. Even if manufacturers are able to spend more on manufacturing, the skilled workers needed to run these new machines are missing. 40% of manufacturers say that with an aging workforce, skilled workers are virtually impossible to find. So, companies are asked to do more with less. The problem is that recent trends in manufacturing aren't looking good. Over the past 10 years, overall productivity of global manufacturers has increased just 3%. That's 0.3% increase per year in productivity. This is a major problem for manufacturers. 61% of CEOs polled say that their biggest barrier to delivering more innovative products to their customers is engineering productivity. So we cannot continue as we do today. We need to do more with less negative impact on the planet. Addressing the inevitability of having to do more, along with the reality of doing it with less negative impact, is a massive challenge. But addressing this fundamental capacity issue is also the biggest design and manufacturing opportunity we have ever had. It is up to us to turn a challenge into an opportunity of better. Despite the trends, CEOs generally see this as an opportunity for their companies. 95% of CEOs see technology changes as an opportunity for them to thrive. Just want to repeat that. 95% of CEOs see technology changes as an opportunity for them to thrive. Our answer is to help companies innovate and increase productivity by connecting and automating the design and manufacturing with the convergence of design and manufacturing. Recently, I was reading an article from Forbes where Bernard Marr wrote about the 9 mega technology trends and how they are reshaping our world today. Now, I'm not going to hit on all of these, but there are a few of them that if a company were to embrace, can help them with their competitive advantage. Because all of these together are disruptions, and they're disruptions for your company, they're disruptions to your return on investment, they're disruptions to your bottom line. So out of these 9, let's start with computing power. What you see is a supercomputer at Oak Ridge National Laboratories called the Titan. This is a government facility in the United States, and not everybody has access to something like this. Supercomputing is just that, it's super. But how do you, as a small or medium or an enterprise company, accept and be able to become competitive for people that do have supercomputing power? High performance computing enables you to increase the speed of research and reduce time to results by running high performance computing in the cloud and scaling to a large number of parallel tests than would be practical in most on-premise environments. What this is saying is that something similar like Amazon's cloud is bringing HPC for the 99% of the people. So if you do not have the capability, the capacity, or access to a supercomputer like the Titan at Oak Ridge National Laboratories, you are able to leverage the same supercomputing power in the cloud. And that's a key word that we're going to talk about, is the cloud. The second mega technology trend is artificial intelligence. What you see on the screen is lightning motorcycles which produces the fastest electric motorcycle on the planet. How are they utilizing this technology? For example, the old way of doing design is when you have a human and you have a computer and you input your team's ideas into the computer for product X. However, you're only getting limited design options. And those design options may not be the best design option, but you are bound by time. You are bound by different impacts to coming up with the best design. So your concepts may be limited, but they're based on, is it the material or the manufacturability? Do you have enough time to do validation? Bottom line, it literally is your time to market. How are you able to go from concepts to production faster than your competitors? Let's talk about the new way of doing design. The one human or the human team is still consistent. But now you are incorporating machine learning algorithms or artificial intelligence with unlimited cloud computing power, which are going to allow you to yield hundreds, if not thousands, of different design options. Let's watch a quick video that describes this for us.
What if you could come up with thousands of options for a single design without drawing, all of which meet specific goals set by the designer? And from those options, pick the one design that delivers on the most important criteria, the design you couldn't possibly have imagined. This is generative design, a technology that harnesses massive computing power, creating forms with precise amounts of material only where needed, achieving maximum performance while wasting nothing. But generative design can be about much more than simply turning out alternatives. Prototypes can be scanned and equipped with sensors that provide real-time performance data that can be looped back into the design process, so the object, in effect, co-designs itself. And depending on the material and method of manufacture chosen, the software can optimize the design for those choices. In its search for the optimal design, generative design creates complex forms that would otherwise be impossible to make using traditional manufacturing methods. Now, with advancements in material science and the ability of 3D printers to print metal, companies like Airbus can create forms like this airplane partition panel that's half as light and just as strong. The result? Significant reduction in fuel costs and CO2 emissions. The things that have limited us in the past, software, materials, manufacturing, no longer do so. With generative design, the world can look and perform any way we want it to. This is the next stage in the evolution of design, and it's happening now.
I thought a big takeaway from the video was the quote, achieving maximum performance while wasting nothing. This begs the question, are you taking advantage of these tools that are commercially available today? An additional question also has to be asked, what is your competition doing in this space? So as we look at what we just learned in that video, now we can see how this really impacts your business. Generative design provides validated design alternatives by evaluating the problem, strength, and performance requirements and manufacturing processes all in parallel, performing the function of generating geometry based on multiple criterion and freeing the geometry creation burden from the engineer, thus enabling them to explore a much wider solution domain, expose more information about validated and manufacturable options in order to make the most informed decision about what is best for the business. So if you look at the bottom, what you're getting is a faster time to market based on more validated options, allowing you to make the best decision. Generative design is a design exploration technology. You can simultaneously generate multiple solutions based on real-world manufacturing constraints and product performance requirements. Let's take a look at another video that will help us with this understanding. Utilizing the motorcycle again, you select 2-3 different areas. areas that you need to preserve, obstacles you need to avoid, as well as the types and amount of loads that you want to put on your design. Now you're leveraging supercomputing power in the cloud, as well as artificial intelligence to help you make the best designs possible, allow you to select the best designs possible. Every dot is a different design based on strength, stiffness, or the mass. And now you can start playing what if examples by putting the different designs in there that'll help you understand and make the best decisions possible that you would never have been able to do in the past. Ultimately helping you select and differentiate yourself. And then it goes into how you want the part to be manufactured. Obviously, you're going to still be using some subtractive manufacturing methods. Being able to do this all within the same window is critically important. Let's take a look at another trend, which is 3D printing, historically known as rapid prototyping and now known as additive manufacturing. You saw in the video about what is generative design, some examples from Airbus. This is the Airbus partition, but it was not just about coming up with a new design that looked organic or structurally superior. Airbus has to make business decisions. They wanted to reduce the weight of the aircraft at delivery. They wanted to save on future fuel costs. They also needed to signal the market that their thought leader position is number one. So we take a look at the partition. This is what it looked like after 3D printing or additive manufacturing. This is the nested product. What's also interesting to note is that they invented a new alloy called scale moly. Let's take a look at the video of how Airbus utilized generative design for their partition. Every dot is a different design based on stress, based on force, and these always change based on the needs of the design, not on the needs of what a designer wanted to do. They started to get a better look of these thousands and thousands of different designs to help them make the best decision. Once again, every dot is a different design, which helped them make the best decision for their product. Now, did they want to make it stiffer, heavier, lighter, stronger? All of these different choices help them come up with the best design. Let's look at another company. General Motors plans to launch 20 new all-electric vehicles by 2023. General Motors believes in an all-electric future. So what are they going to do to help them? They looked at one of their products, which is the seatbelt harness. They also had business impacts they needed to make. They needed to save on material costs. And they needed to simplify their supply chain and increase performance. Let's take a look at what General Motors is doing.
At General Motors, we're all about putting our customers first and at the center of everything we do. If we can take a mile per gallon of fuel economy off, if we can extend our range 10 miles in an electric vehicle, that can be a huge competitive advantage for General Motors. As you start looking into the future, generative design paired with additive manufacturing can be completely disruptive to our industry to deliver those functionally optimized designs and deliver performance to our customers that they couldn't get any other way. We've been doing additive manufacturing at GM for over 30 years. Rapid prototyping, assembly, tooling, jigs, fixtures. How do we take that next step? Getting people to think differently. Not migrate back to, well, we can't do it. Additive manufacturing can enable us to do this. We have some very unique design challenges in some of our upcoming vehicle programs. One of those was the seat bracket. That seat bracket is very important from a functional safety perspective. How can we fully functionally optimize that design for mass? We chose to use generative design as our design tool to come up with different options for the seat bracket. Normally when we face a design challenge like that, we may come up with 2 or 3 different design options, but with generative design, we could come up with over 150 some solutions that we just couldn't have thought of with any other existing design tools. We formed a partnership with Autodesk. We thought it was a unique opportunity to really use those tools to deliver a design that we couldn't come up with any other way. We've run it through our normal set of test procedures that are required for this part. This part is so much better than the previous part. 40% mass savings, at the same time getting 20% stronger, far exceeded my expectations of what we could achieve. We have many different parts and pieces on our vehicles, over 30,000 on average. So now the real challenge is to find all those different applications where we can apply the same principles of generative design to really optimize our vehicles further.
Let's look at our last example of the mega technology trends about interacting with technology. We're going to move to Germany, where Claudius Peters was founded in 1906. Claudius Peters is serving the heavy-duty industries, and they are a leading manufacturer of material handling and processing systems that can be found in cement, gypsum, steel, and aluminum plants across the globe. So as we were looking at Airbus and a partition and General Motors with a seatbelt holder, let's look at how generative design is helping industrial manufacturing.
Claudius Peters provides machines and process plants since 112 years. Our business is very cost-driven, so the customer is expecting us to deliver faster, to deliver cheaper. We have to change how we do things, how we engineer, how we make projects and products.
Claudius Peters loves to experiment with new technologies and new ideas, so I came up here one day and I gave them a half a day of training on generative design.
At first I thought that the workshop was just for fun. We were designing and using some easy parts, but we ended up recreating a real part from Claudius Peters.
We were completely surprised about the shape and what generative design made out of our already optimized part.
The oldest engineer in the house actually did some calculations and said himself, wow, I didn't really think that was going to work, but this part is a lot better, even better than the optimized part I created yesterday. And from that point, they began to iterate on that rather spacey looking design and think about how they might be able to manufacture that part using traditional techniques.
We took the proposal from generative design and we engineered it reversed so that we can do it with traditional manufacturing methods. So when you use generative design, you have to rethink as a designer. Generative design requires that you model the constraints. You do not think of a part or how does this part look like. You think what is the requirement, what are the loads, what are the constraints of a part. And then generative design is giving you possible designs.
Before Autodesk Generative Design, the optimization process took several weeks, even months. Now, with Autodesk Generative Design, it took us half a day. To work with Autodesk Generative Design is easy, fast, and the outcomes are great. I love it, plain and simple.
It's amazing what you can see with a company that's 106 years old that are utilizing and leveraging new technology like the cloud and artificial intelligence to make their products better. You saw a lot of the different designs that they were coming up with and how they tested a lot of the new solutions they were able to make the part lighter and faster and obviously more cost efficient. The unit on the left coming in at 168 kilograms versus the new design on the right at 52 kilograms. What's important to understand is they were utilizing generative design for the inspiration for a new design that they're still manufacturing the same way. It's important to understand is that they are reducing the weight by 256 pounds per unit. And when they look at an overall savings for the smaller assembly, they do 7 per year, it's a savings of 14.3 tons. And on the bigger unit, savings of 58.2 tons of metal that they are no longer utilizing. Much more than that, they were able to change their manufacturing method and the outsourcing. These parts were coming casted from Cambodia, and now they're welded in their local factory, which prevents the stocking and handling and storage of the parts, and they weld as needed. So in addition to General Motors, Airbus, and Claudius Peters, and electric motorcycles, let's see how we're utilizing our own technology at one of our office spaces. We wanted to run an experiment to discover how we could maximize productivity and create a great environment for the people working at Autodesk. Utilizing generative design, we were able to input the forces that are influencing human productivity. We surveyed our employees and captured their preferences and work habits. And then it generated thousands of alternative floor plans, all in the time it would take us to draw just one. The system sought to minimize distractions, maximize outside views, and prioritize personal relationships. Just as you saw the previous examples, when these were put into the system, we came up with the best possible design. Literally dozens and dozens and hundreds of variations. Let's take a listen to this video of the benefits of using generative design.
Generative design is starting by specifying the high-level goals and constraints of a project, and then using the power of computation to automatically generate, evaluate, and evolve hundreds or thousands or even hundreds of thousands of design options to explore a very wide design space of possibilities.
I call generative design my virtual design associate. It takes care of all the process work and option analysis.
We've been using it to design many different iterations and try new things. It's given us the ability to test things very, very quickly.
A lot of people think of computers and they think of automation and they instantly sort of say, oh, does that mean you can do everything in a fraction of the time? But for us, we don't think it's so much of reducing the timelines where something that takes you 100 hours suddenly reduces to 50. It's the fact that what you can do within those 100 hours is so much more.
There are definitely benefits to generative design, such as reduction in waste. As a designer, you'd be more connected to the manufacturing, and having that close connection from the designer's point of view to the manufacturing is an added value.
It could be the zoning of the site, it could be the sustainability factors, and imagine if you mix all those things and feed it to the computer system, it's create a better series of options that you can then pick and choose based on your taste and implement it.
We get to see things that we never conceived of. And by doing so, we get to go and try it, do it, and actually make better design. I think that's the best thing that everybody wants altogether.
For us, it's continually sort of saying, what's the next step in being able to sort of take this that little bit further, apply a little bit more extra effort, and get a lot more out of it.
The good news is we weren't just pushing cubicles around, and we were not just stuck with the first floor plan that worked. This all starts with putting your data at the center. When you put data at the center of your processes and connect it to the right people at the right time, you break down the silos in the design process. Putting data at the center enables the connection of tools, processes, and people. And at once the people and processes are connected, you can automate the processes themselves. Generative design, for example, automates the ideation process, giving the user the ability to easily explore all valid geometric options for a given set of materials, manufacturing processes, and operating conditions. And because you ultimately need to get a physical product in the hands of your customers, we're making it possible to connect into your manufacturing facilities, even if that extends across the boundaries of your organization into your supply chain. In review, we covered 5 of the 9 mega technology trends today. And as President Moon Jae-in declared in June, we hit on a few of those that are important to South Korea. Thank you for your time.